What is economics? Economics is the study of how scarce resources are allocated in order to satisfy unlimited wants. There are three players in this allocation of goods and services: sellers, consumers, and the government, but we'll just focus on the interaction between sellers and consumers. Sellers, who supply goods and services, wish to maximize profit. But what exactly is profit? Profit's the amount a seller makes over a period of time after they account for the cost to produce their goods and services. We can write this as profit equals total revenue minus total cost, which can be given by the following formulas and symbols, where Q is quantity, capital P of Q, R of Q, and C of Q are just profit, total revenue, and total cost at Q units respectively. For example, suppose we wish to sell cupcakes for $5 each, and we sell 100 of them. It costs us $200 total to make them. What's the profit? Well, Q, quantity, is given as 100 cupcakes, and lowercase p, price, is given as $5 per cupcake. So total revenue would just be our price times our quantity sold, or $500. Our total cost was given to us as $200. Therefore, to find our profit, we just subtract these two numbers and get $300. A question we can ask ourselves is, can we raise our profits by charging more? Maybe, but we might also make less. Not only will our costs go up, but our revenue might actually go down. To see why, we need to explore the law of demand. Demand shows quantity consumers are willing to purchase at various prices. The law of demand states that this curve has a negative slope, meaning the higher the prices, the less consumers want to purchase. Since total revenue is price times quantity, or just the area of this rectangle, it's possible that if we were to raise our price to $10 per cupcake, our sales might actually decrease by so much that total revenue declines. So, in order to maximize profits, businesses must choose their prices carefully, and we can demonstrate this using calculus. First, find the total revenue and cost functions. Note that we might need to use the demand function to derive the total revenue function. Next, find the profit function by subtracting revenue and cost. Then use the first derivative of the profit function to find that profit maximizing price. Note that if you've had microeconomics, you might have learned that you can find the maximum profit by setting marginal revenue equal to marginal cost. To see why, instead of taking the derivative of the profit function, we can instead take the derivative of the revenue and cost functions, called marginal revenue and marginal cost, subtract them, then set that equal to 0. By adding marginal cost to both sides, we can get the rule that maximum profit occurs when marginal revenue equals marginal cost. Let's use this procedure in an example. A store is marketing a new laptop. It's determined that in order to sell Q laptops, the price must be P equals 280 minus 0.4Q. Note that this is just the demand function. It's also determined that total cost is C of Q equals 5,000 plus 0.6Q squared. Find the total revenue and profit functions, and the price and quantity that maximize profit, as well as that maximum profit. Let's start off by trying to find the revenue and cost functions. Well, we already told the cost function. The cost function is just C of Q equals 5,000 plus 0.6Q squared. Now, in order to find the revenue function, we weren't given a revenue function, but we were given that the demand was P equals 280 minus 0.4Q, which means that total revenue, we know, is just price times quantity. We can plug this demand equation in for price and find our revenue function as a function of Q. So R of Q is equal to, plugging in P into the revenue function, so we get 280 minus 0.4Q times the Q that's already in revenue. Distributing this out, we get 280Q minus 0.4 q squared. All right, so putting these two together, and there's two ways to do this, but let's do it the more traditional way. We know that profit, P, you can say P is a function of Q, and this is capital P for profit. Profit is equal to revenue minus cost. Well, revenue, we just figured out, was 280Q minus 0.4 Q squared. Now let's subtract cost, and our cost function was up here. So minus, let's put in parentheses so we know to distribute that negative, 5,000 plus 0.6 Q squared. So next, let's distribute the negative, and we get 280Q minus 0.4 Q squared minus 5,000, and then distribute the negative, gives you minus 0.6 Q squared. Combining like terms, let's do the highest degree term first. So we have two Q squared terms. Combining those, negative 0.4 plus negative 0.6 gives you negative 1. So negative Q squared plus 280Q minus 5,000. So this is our profit function. So we've answered the first two parts of this question, which was to find the revenue function and find the profit function. Now that we have the profit function, we can use the first derivative to find the critical point, and this critical point will tell us where the maximum is. Technically, we should check the second derivative to verify it's a profit maximizing point instead of profit minimizing point. But because of the shape of this curve, I know that it's going to be concave down. I know the curve ultimately is going to look like this, which means that it will be a profit maximizing point. So I will skip that step. All right, so let's take the derivative of the profit function and then set it equal to 0. So the derivative of negative q squared is just negative 2q plus 280. The derivative of negative 5,000, I left off a 0 there, is just 0. Set this equal to 0 and solve for q. So you'd add 2q to both sides, then divide by 2, and ultimately get that q is equal to 140. So this is the profit maximizing quantity. To find the profit maximizing price, so lowercase p, we were given that our demand function, p, lowercase p, was equal to 280 minus 0.4q. Since we know the profit maximizing quantity is 140, I'll just plug that in. And so that gives me 280 minus 56, I believe. So that gives you 244. Putting this more in the words of the problem, remember this was the price of laptops in dollars per laptop, and quantity was measured in number of laptops. So you could say that the profit maximizing quantity is 140 laptops, and the profit maximizing price is $240 per unit, or each, or per laptop. I'll just write it as per laptop. To find the actual profit maximizing profit, so to find the actual maximum profit that you can receive, we already know our profit function is over here. So let's plug in our profit maximizing quantity. So our profit maximizing quantity was 140 laptops. So you plug that in, you get negative 140 squared, and minus, this is, note that this is like a negative in front of the 140 being squared, plus 280 times 140 minus 5,000. Taking out a calculator and plugging this in, we would get that the maximum profit is $14,600.